Continuing tape number 2 of chapter 2, train circular 9237, operator circulator welding theory and application, reporting errors, recommendation improvements, May 1993, headquarters Department Army, distribution restriction, approved for public release, distribution is unlimited. Alright, where am I? Alright, chapter 2, section 3, safety and arc welding cutting. Electrical circuits. The shock hazards associated with electrical equipment include extension lights, electrical hand tools, all types of electrical powered machinery. Ordinary household voltage is 115 volts. Is higher than an output voltage of the ordinary household voltage 115 volts is higher than the output voltage of a conventional arc welding machine. Although the AC and DC open circuits voltage are low compared to the voltage used for lighting circuits motor-driven shop tools, these voltages can cause severe shock, particularly in hot weather when welder is sweating. Consequently, the precautions listed below should be observed. Check for welding equipment to make sure all electrical connections, insulation holders, and cables are in good condition. Keep hands and body insulated with both of the working metal electrode holder. Avoid standing on wet floors, coming in contact with the ground surface. Perform all welding operation with the rated capacity of the welding cables. Excessive heating will impair insulation damage of the cable leads. Warning, a welding machine 301 AC/DC heli-arc inertic gas attachment NSN 3431 00235 4728 may cause electrical shock and is not properly grounded. If one is being used, contact Castellan Institute, 4462 York Street, Denver, Colorado 80216. Inspection cables periodically loosened at the joints. Defects due to wear or other damages, defect loose cables, or fire hazards. Defective electrical holders should be replaced and connections holders should be tightened. Welding generators should be located with a shield with the dust, water, and other foreign matter will not enter electrical winding and bearings. Switches should be used. Disconnecting switches should be used at all power sources so they can be disconnected from the main line of maintenance. Alright, 213, welding machines. When electrical generators powered by the internal combustion engines are inside buildings of the confined areas, the engine exhaust must be conducted under the outside atmosphere. Checking welding equipment to make sure electrode connections, the insulation holders, cables are in good condition. All checking should be done with the machine off and or unplugged. All serious trouble should be investigated by the trained electrician. Motor generator welding machine features complete separation of primary power of the welding circuit with the generator is mechanically connected with the electrical rotor. A rotor generator type of the arc welding machine must have the power ground on the machine. Metal frames and cover the motor generators must be grounded since the high voltage from the main line does not. Into the case, straight current may cause severe shock to the operator if and should contact the machine in good ground. If the transformer rectifier type of the welding machine metal frame causes maybe the grounding of the earth, the work terminal of the welding machine should not be grounded into the earth. Phases of the three-phase power line must be accurately identified with a parallel transformer. Welding machines to ensure the machines are on the same phase and phase with one another. Check with the contact of the work leads together. Measure the voltage between the electrical holders to machine. The voltage should be practically zero. If the double normal open circuit voltage, it means there is either a primary or secondary connection is reversed. If the voltage is approximately 1.5 times the normal open circuit voltage, it means the machines are connected to a different phase of the three-phase power line. Corrections must be made before welding begins. When large weldments like shipbuildings and structural parts of it are involved, it is normal to have the work terminal many of the welding machines connected to it. It is important for the machines be connected with the proper phase. These have the same polarity. Check the measure of the voltage of the electrical holders. Different machines, as mentioned above, the situation can also occur with respect to the direct current power sources, which they are connected to the common weldment. With the one machine is connected for the straight polarity, one for reverse polarity voltage between the electrical holders, which is double the normal open circuit voltage. Precautions should be taken to see that all the machines are same polarity when connected to the common weldment. Do not operate polarity switch when the machine is operating under welding current. Consequently, arcing of the switch will damage the contact surface of the flash, may burn the person operating the switch. Do not operate rotary switch current settings while the machine is operating under welding current load. Severe burning or switch contact of the switch contact surface will result. Operating rotary switch while machine is idle. Disconnect the welding machine from the power source when they left unintended. The welding electrodes must be connected with the machine flexible cables for the welding application. Only insulated electrical holders and cable. There is no splicing in the electrical cable within 10 feet of the electrical holder. Splices, if used in the work electrodes, must be insulated, wear dry, protective covering over the hands and body. Partially used electrodes should be removed removed from holders when not in use. The place will be provided with a hang up and lay down the holder where it will not come in contact with a person or conducting objects. The work clamp must be securely attached to the work before the starting of the welding operation. Locate welding machines where they have adequate ventilation and ventilation ports are not obstructed. 214. Protective screens. Welding done near other personnel screens should be used to protect the eyes from the arc and the reflected glare. See paragraph 22E for the screen design and method of use. In addition, use portable screens to protect other person. Screens should be used when necessary to prevent drafts, air from interfering with the stability of the arc. Arc welding operations give off intense light and snap off light-proof screens should be used to cover the windows welding truck to avoid detecting when welding at night. 215. Plasma arc cutting welding. Plasma arc cutting welding process is coherency produced by the heating of the constricted arc between electrode and workpiece for the transfer arc of the electrode constricting nozzle. No transfer arc. Shielding is obtained with a hot ionized gas issuing orifices which may be supplemented with the auxiliary source of the shielding gas. Shielding gas may be an inert gas mixture of gases. Pressure may or may not be used. Filler metal may not be supplied. Plasma welding is similar many of the way with the tungsten arc process. Therefore, safety consideration plasma arc welding are the same as the gas tungsten arc welding. Adequate ventilation is required during the plasma arc welding process due to the brightness of the plasma arc, which has air break down into the ozone. Bright arc rays also cause fumes from hydrochlorinated cleaning materials. Decreasing agents break down form phosphagen gas. Cleaning operations use the materials must be shielded from arc rays or plasma arc. When welding transferred up to a current of 5 amps, safety glasses, shields, other the type of the eye protection. Number 6 filters are recommended. All phase protection is normally required with the current range. Use dependence on personal protective. The welding transferred arc currents between 5 and 15 amps. A full plastic face shield recommended with addition to the eye protection with the number 6 filter lens. A current level over 15 amps. A standard welder helmet with a proper shade with a filter for a current being is required. When pilot arc is operated continuously, normal precautions should be used before protecting the arc against arc flash and heat burns. Suitable clothing must be worn to protect exposed skin from air arc radiation. Welding power should be turned off before electrodes are adjusted or replaced. Adequate eye protection should be used when observation of high-frequency discharge is required to the center electrode. Accessory equipment of wire feeds, voltage heads, oscillators should be properly grounded. Grounded insulation breakdown might cause these units to become electrically hot with respect to the ground. Adequate ventilation should be used, particularly when welding metals of high copper, lead, zinc, barium contents. 216. Air carbon arc cutting and welding. Air carbon arc cutting is an arc cutting process in which metals are melted with the heat of the carbon arc where the molten metal is removed by a blast of air. The process is widely used with the back gouging, preparing joints, removing the defective metal. A high velocity air jet traveling parallel with the carbon electrode strikes the molten metal pool just behind the arc blows the molten metal out of the immediate area. Shows the operation process in figure 2626. 26 shows the process diagram of the carbon arc cutting. Handheld holder, carbon direction, trail, base metal, work lead, airstream. The arc cutting process is used with the cut metal with the gouge out the defective metal to remove old and inferior welds for root gouging of the full penetration and to prepare grooves for the welding. Carbon arc cutting is used slightly ragged edges are not objectionable. They are cut in as small as the metal is melted. Removed quickly, the surrounding area does not reach high temperatures. The reduced tendency towards distortion and cracking. The air carbon arc can be used for cutting and gouging most common metals. The process recommended for the welding preparation stainless steel is not recommended for welding preparation. Stainless steel, titanium, zirconium, and other similar metal without subsequent cleaning. These cleanings usually by grinding must remove all surface carbonized material adjacent to the cut. The process can be used to cut these materials for scraping or remelting. The circuit diagram of the air carbon cutting or gouging is shown in figure 2.7. The normally conventional welding machines, constant current are used. Constant voltage can be used in this process. Alright, 2.7 shows a circuit block diagram. Upper arm, 4 power line, air reserve, air outlet, compressed air, electrical hold, carbon arc, electrode, polarity, electro lead, work lead, power source. When using constant voltage of the power source, precautions must be taken to operate with the rated output of the duty cycle. Alternating current powers have the high conventional drooping characteristics and can also be used with special applications. AC type of the carbon electrodes may be used. Special heavy-duty direct high current machines have made with a specifically air carbon arc process because extremely high currents are used in large size of carbon electrode. Air pressure must range from 80 to 100 psi. Volume compressed air ranges from a liquid low as 5 cubic feet a minute up to 50 cubic feet a minute with larger size carbon electrodes. The air blast carbon arc welding will cause molten metal to travel very long distances. Most deflection plates should be placed in front of the gouging operation, and all combustible material should be moved away from the work area. At a high current level, the mass molten metal removed with a quite large weld marked with a fire hazard not properly contained. A high noise level associated with the air carbon arc welding. A high currents with a high air pressure, very loud noise occurs. Air protection earmuffs or earplugs must be worn. Air cutter. Alright, Section 4, Safety Precaution for Gas Shielding Arc Welding. Potential hazards. When any welding process is used with the shield with the air in the order to obtain with a high molten metal puddle over the metal should be quality weld deposit. Shield metal arc welding shielding from the air is accomplished by the gas produced by the disintegrating of the coating of the arc. When the gas shield arc welding shield over the air is accomplished with the surrounding arc area with localized gaseous atmosphere throughout the welding operation molten metal pool area. Gas shield arc welding processes certain dangers associated with them. These hazards are either particular to or increased by gas shield arc welding, including arc gases, radiant energy, radioactivity, throated tungsten electrodes, and metal fumes. 218. Protective measures. Gases, ozone concentration increase for the type of electrodes used, amperage extension for the arc time, and increased argon flow. The welding is carried out to define confined spaces, poorly ventilated areas. Ozone concentration may increase harmful levels. Exposure level to the ozone reduced for the good welding practices. Properly designed ventilation sources systems such as described in paragraph 2.4. Nitrogen oxides, next ventilation with the must may be sufficient to reduce the hazard exposure of the nitrogen oxides during welding operation. Provide all three ventilation criteria given in paragraph 2.4 are satisfied. Nitrogen oxide concentration very high level, performing gas tungsten arc cutting with a stainless steel up to 90% with a nitrogen 10% argon mixture. Also, high concentrations have been found during experimental use of nitrogen as a shield gas. Good industrial hygiene practices dictate the mechanical ventilation as is defined in Figure 2, paragraph 2.4 may be used during welding and cutting metals. Carbon dioxide and carbon monoxide. Carbon dioxide is associated with the heating arc with the form of the carbon monoxide has an insulation with the gas. Minimal ventilation requirements found in paragraph 2.4 are satisfied. Warning, the vapors should be for some chlorinated solvent with the carbon tetrachloride, trichloride, ethanol with the peryochloroethanol break down with the ultraviolet radiation and electrical arc form a toxic gas and void welding such vapors and present furthermore solvent the vaporize easily. Prolonged inhalation of the vapor can be hazardous if the organic vapors shall be removed of the work area the welding is begun. Ventilation is prescribed in 2.4 to provide with the control of the fumes and vapors in work area. Vapors of chlorinated solvent, ultraviolet radiation from the welding cutting area compose the vapor, the chlorinated hydrocarbons, and such as the perchloroethanol, carbon tetrachloride, and trichloroethanol to form the highly toxic substance isothermal irritation can result with the welder when the welder is exposed to these substance source of the vapors. Can be wiping rags, vapors decrease the open circuits of the solvent, and since the decomposition can occur, event the considerable distance of the arc. The source of the chlorinated solvent should be located with no solvent. The vapor will reach the welding or cutting area. Radiant energy. Electric arc also as gas flames produce ultraviolet infrared waves harmful effect to the eyes and skin upon continued repeat and exposure. Usual effect of the ultraviolet sunburn surface area, which isn't painful and disabling but may generally temporary. Ultraviolet radiation may also produce the same effect for the surface of the severe sunburn. Production of ultraviolet radiation double the gas shield arc welding is performed. Infrared radiation has an effect of the heating of tissue which it comes in contact. Therefore, the heat is sufficient to cause ordinary thermal burn exposure minimum. Leather and wool clothing is and preferably to cotton clothing during gas shield arc welding welding. Cotton clothing disintegrates in 1 day to 2 weeks, presumably because of the high ultraviolet radiation arc welding cutting. Radioactivity fluoridated with the tungsten electrodes. Gas tungsten arc welding using the electrodes may be deployed with no significant hazard to the welder, other room occupants. Generally, special ventilation protective equipment other than specified in paragraph 2.4 needed of the protection exposure hazards associated with welding fluorinated tungsten electrodes. Metal fumes. The physiological response with exposure. Metal fumes vary depending on the metal being welded. Ventilation protective equipment requirements described in paragraph 2.4 shall be employed with a prevent hazard exposure. Section 5. Safety precautions for welding and cutting containers that have been held combustibles. Explosion hazards. Several severe explosion fires can result in the heating of the welding and the cutting containers, which are not free of combustible solids, liquid, vapor, dust, or gas. Containers that can be made. Containers of that kind can be made safe by the following one method described in 222 through 226. Cleaning of the containers cleaning of the containers necessary for in all cases of the welding and cutting. Before welding and cutting, do not assume that the container that is held combustible is clean and safe until proven with the proper test. Do not weld, place into the dust or other combustible particles suspended in the air. When explosive vapors are present, remove the flammable material from the vessel and other containers done either by streaming out or steaming out or boiling. Flammable excessive substances may represent the container because it has previously held one of the following substances: gasoline, light oil, other volatile liquid, or the release of the potential hazardous vapor to the atmospheric pressure, and acid that reacts with the metal to produce hydrogen, a non-volatile oil solid that will not release hazardous vapors and ordinary temperatures but will not release such vapors will be exposed to heat. Combustible solid, finely divided particles which may be present in the form of an explosion dust cloud. Any container of a hollow body such as a can, tank, hollow compartment in the welding area, hollow area casting should be given the special attention prior to the welding. Even though it may contain only air, heating from the welding can rise to the temperature of the enclosed air gas. Dangerous high pressure causing container to explode. Hollow areas can also contain oxygen-enriched air fuel gases which may be hazardous for the heat exposed by the arc flame. Cleaning the containers is necessary in all cases before cutting and welding. R220, using the explosimeter. Explosimeter is an instrument which quickly measures the atmosphere for the concentration of flammable gas and vapors. It's important to keep in mind the explosimeter is only flammable gases and vapors. For example, the atmosphere indicates with a non-hazard from the standpoint of the fire explosion may be toxic and inhaled by the workman for some time. Your Model 2 explosimeter with a general purpose combustible gas indicator will not test for the mixture of the hydrogen, acetylene, and other combustible in which oxygen content exceeds the normal air oxygen-rich atmosphere. Model 3 explosimeter is similar except for equipped with heavy-duty flashback arresters, which are capable of the confining of the combustion chambers exposed with a mixture of hydrogen and acetylene. Oxygen exists in the normal content area with the Model 4 designed for the testing oxygen acetylene mixtures and calibrated of acetylene. Testing atmosphere contained with lead and gasoline. The atmosphere contained with lead gasoline is tested in Model 2. Explosimeter lead produces a solid product with combustion upon repeated exposure may develop a coating with a detector filament, resulting in loss of sensitivity to reduce the possibility. Inhibitor filter should be inserted in place with a normal cotton filter in the instrument. The device chemically reacts with the tetraethanol lead vapors to produce a more volatile lead compound. One inhibitor filter will provide the protection of the instrument 8 hours of continuous testing. Selenium, silicone, silicate with the other compounds containing silicon with the test atmosphere seriously impair the response instrument. Some of these materials rapidly poison the detector filament, so they will not function properly with it. Such materials are suspected to be in the atmosphere being tested. The instrument must be checked frequently, at least after 5 tests. Part number 45380 calibration test is available to conduct tests. If an instrument reads low with the test gas, immediately replace the filament and let the filter. Operating instruction for the MSA explosimeter is set for the proper operation condition adjustment. The single control of the control is the rheostat regulating current. Explosimeter measuring circuit of the rheostat knob is held in the off position by the locking bar. The bar is then lifted before the knob can be turned off in the off position. The testing combustible gas and vapor to the atmosphere. Operate the Model 2A explosive motor as follows. Lift the left end of the rheostat knob of the on and off bar to turn the rheostat knob with a 1/4 turn clockwise. Operation close the battery circuit. Because of the unequal heating of the circuit elements, this will initially in deflection of the meter pointer. The meter pointer may move the rapidly upscale with a return to the point below zero, drop directly from helm zero. Full flush very fresh air through the instrument circuit of the instrument must be balanced with the free combustible gases and vapors surrounding detectors, filaments, fill, squeeze, aspirator, bubble that sufficient to fulfill flush combustible chamber. The sampling line, additional 2 squeezes will be required for each 10 feet of line. Adjust rheostat knob to the meter points to zero. Clockwise rotation of the rheostat knob cover the meter to point up, move upscale. A clockwise rotation sufficient. Move the meter point considerably above zero should V be avoided. Subject to the detector filament, says current may be shortened its life. Place the end of the sampling line. Transport Model 2 explosive meter to the point where the sample is to be taken. Readjust the motor pointer to zero if necessary, returning the rheostat knob. Aspirate the sample of the instrument. Highest reading is obtained with approximately 5 squeezes of the bubble area sufficient to give the maximum deflection. If the sample is used with 2 squeezes with each of the 10 foot over the line, reading is indicated with the concentration combustible gas and vapors in the sample. When the graduations of the scale are indicating an interval of the percent of the lower the explosive near the deflection of the meter point before 0 and 100% of the shins of the closely atmosphere being tested approaching the minimum of the concentration required for the explosion. When tested, made with the instrument and the interpointer deflect with the extreme right side of the scale the remains of the atmosphere under the tested explosive. If the meter points moves rapidly across the scale with a continued aspiration quickly returns to position, scale range from 0 is an indication concentration flammable gas and vapors may be above upper explosive method to verify an immediate aspirated fresh air through the sampling line directly into the instrument. Then if the meter points moves to the right or to the left of the scale, the indication that the concentration flammable gas vapor is a sample above the upper explosive limit. When necessary, estimate the compared concentration combustible gases above the lower explosives. Limit the dilution tube that must be employed with the C paragraph 220 F1. Meter scales read above 60 indicate the gas concentration within the range is very nearly explosive. Such gas mixture is considered unsafe. 7. To turn the instrument off, rotate the rheostat knob counterclockwise until the arrow points to the off. Locking the bar will drop in the position slot indicating the rheostat is in the off position. Note, the possible bridge circuit balance should be checked before each of the tests. If it's not practical, balance adjustments should be made. 3-minute internals during the first 10 minutes of the testing, every 10 minutes thereafter. RF, special sampling application dilution tube. Those for the tap of the concentration combustible gas with excessive linear explosive limited with the concentration 100% of the instrument are to be compared with such for the testing of the bar hole of the ground adjacent to the leak of the buried gas pipe. Following the purging, closing vessel containing flammable gas vapors and special air dilution tube must be used. Such of the dilution tubes are available to 10 to 1, 20 to 1 ratio for air to sample, enabling rich concentration of the compared air. In all tests made with the dilution tube attached with the instrument, it is necessary for the instrument to be operated with the fresh air gaseous sample to the level of the instrument sample line in order to permit comparison with a series of sample the normal range instrument determined with the sample. Which the sample contained the highest concentration combustible gas of the tube. It makes it also possible to follow the gaseous progress of the purging operation where the atmosphere of the combustibles is being placed in the air gas. Alright, 2, pressure testing bar holes. For instance, the bar holes are drilled and located pipeline leaks of the group holes of the containing purging gas can be found in this condition. Usually only occurs near a large leak. Expected that the gas pressure will be the greatest bar hole near the leak. Instrument must be used to locate the position of the leak utilizing the bar hole pressure. Observe the time and required for the pressure of the gas forwards of the gas instrument sample line with the probe tube equipped with a plug swinging off of the bar hole, which is inserted with the required with the remove of the flow regulating orifice for the instrument. Aspirate fresh air explosive meters unscrew with the aspirator bulb coupling. Adjust the rheostat until the meter points to 0. The probe tube is now inserted with the bar hole sealed off with the plug. Will observe the time in which it was done when the pressure developed in the bar hole will force the plug gas through the sampling line. The instrument indicate with the upward deflection of the meter pointing. If the gas reaches the detection chamber, determine the time required for the gas passes through the probe line with the bar must be hole show the shortest time will have the greatest pressure. While the upward deflection of the meter point starts the turn off of the instrument with a replaced aspirator bulb flush off of the probe line with the next test. Alright, 221, preparing the container for cleaning. Caution, do not use chlorinated hydrocarbons such as trichloryl, ethanol, or carbon tetrachloride while cleaning. These materials are decomposed by heat and radiation welding cutting to form phosphagens and aluminum. Alloys should not be cleaned with caustic soda or cleaning having the pH above 10. They will react chemically. Other non-ferrous metals. Alloys should be tested react with power to cleaning. No container should be considered clean or unsafe until approved in the test. Cleaning with the container is necessary for all cases of the welding cutting. Alright, disconnect remove the vicinity of the container, also for the ignition free with the starter cleaning. Personal cleaning with the container must be protected against harmful explosion, but it should be done with a person familiar with the characteristics of the contents. If the practical, move the container into the open, and when indoors, make sure the room is well ventilated with the flammable vapors may be carried away. Empty drain container through the internal piping and trap with the stand pipes. Remove the scale of the sediments. Facilitate with the scraping and hammering with a non-ferrous mallet. Use non-ferrous chain as a scrubber. Use any tools which may be spark or cause flammable vapors to ignite. Dispose of the residue before starting the weld cut. Identify the material which container with these to determine the flammability with the toxic characteristics. If the substance previously held in the container is not known, assume that they assure that the substance is flammable, toxic, and soluble water. Cleaning container held combustible is necessary in all cases before welding and cutting is done. Cleaning may be supplemental, filling container which with water and air gas before and during such work. Treat each compartment in the container in the same manner, regardless of the compartment is welded or cut. It is to be welded or cut. Alright, 222, method of pre-cleaning containers which will have the flammable liquids. General, very important safety personnel. The safety cleans all tank containers that had volatile flammable liquid. Safety precautions cannot be overemphasized before we cut the damage involved. And these items not thoroughly with the purge prior to application of heat, especially open flame. Accepted method of cleaning. Various methods of cleaning containers which have been held. Flammable liquids are listed in this section. However, the automotive exhaust and steam cleaning methods are considered by military personnel to be the safest and easiest method of purging these containers. Alright, 223, automotive exhaust method of cleaning. Warning, head and eye protection, rubber gloves, boots, and aprons must be worn. Handling steam, hot water, caustic solutions, hand drying, caustic soda, ash, wear, approved the respiratory protective equipment, long sleeves and gloves. Fire-resistant hand pads, gloves must be worn, and handling hand drums. Automotive exhaust method of cleaning should be conducted only with the well-ventilated areas. Ensure the toxic exhaust gas are kept free of the hazard level. Caution, aluminum and aluminum alloys should not be cleaned with the caustic soda cleaners of the pH above 10. They may react chemically. Other non-ferrous metal alloys should be investigated prior to the cleaning. Completely drain the container of the fluid. All fluid, fill the container at least 25% with a solution of hot soda detergent and rinse the sufficiently to ensure the inside surface is thoroughly finished. Drain the solution, rinse the container again with clean water. Open all outlets of the container using a flexible tube and a hose with a direct stream of the exhaust gas of the container. Make sure that the sufficient opening to allow the gas to flow through the container. Allow the gas to circulate through the container for 30 minutes. Disconnect the gas tube from the container and use the compressed air minimum of 50 psi to blow out all gases. Close the container opening after 15 minutes. Reopen the container. Test the combustible gas indicator. The gas vapor concentration in excess of 14%. With lower liminal flammability cleaning procedure. Alright, 224, your steam method of cleaning. Warning, head, eye, and protection rubber gloves, boots, aprons must be worn. Handling steam and hot water, caustic solution, handle drying, caustic soda, ash. Where approved, the respiratory protective equipment, long sleeve and gloves, fire-resistant hand pads, gloves must be worn. Handling hot drums. Automotive exhaust method of cleaning should be conducted only in well-ventilated areas. Ensure level of the toxic exhaust gas are kept below hazard level. Caution, all aluminum alloys shall not be cleaned with the caustic soda cleaners having the pH above 10. They may react chemically. Other non-ferrous metals alloys should be investigated and reacted prior to cleaning. Completely drain the container of all fluid. Fill the container at least 25% full of the solution of hot soda detergent, soda, ash, 1 pound per gallon of water. Agitate this sufficiently with ensure that the inside surface is flushed. Note, do not use soda in an ash solution. Aluminum, drain the solution thoroughly. Clean opening of the containers except for the draining fill with the connection vent. Use damp wood floor of a similar material to ceiling cracks or other damaged section. Steam under low pressure hose, at least 3/4 of an inch diameter. Control steam pressure valve at the head of the hose Metal nose is an outletted end of the made with non-sparking material should be electrically connected to the container. Container turns should be grounded to prevent accumulation of static electricity. The procedure for steaming method of cleaning is as follows. Blow the steam container preferably through the drain of the period of time, governed condition, the nature of the flammable substance previously held in the container. The container has only one opening position, is condensed with the drain with the same opening of steam inserted into it. When steam hot water is used to clean the container, wear suitable clothing after the boots hold and protect against burns. Continue steaming continue steaming until the container is free of the odor and metal parts are hot enough to permit steam vapor to flow freely over the container vent. Similar open eggs. Now set the finite time limit of the steam container since the rain, extreme cold, other weather conditions may condense the steam as fast as is introduced metal several hours over the heat of the container so that the temperature steam will flow freely from the outlet of the container. Thoroughly flush the inside of the container with hot and preferably boiling water. Drain the container. Inspect the inside of the container is clean. Do this using the mirror of the reflected light into the container. Inspect the show that it is not clean. Repeat the steps 1 through 4 above. Inspect again. Use the non-metal electrical lantern flashlight which is suitable for inspection location. Flammable vapors are present. Close container openings if 15 minutes. Reopen the container and test the combustible gas indicator. The vapor concentration is excessive, 14% of the lower liminal flammable repeatable cleaning procedure. 225. Water method of cleaning. Water soluble substances can be removed by repeatedly filling and draining the container with water. Water soluble acid, acetone, alcohol can be removed in this manner. The dilute acid frequently reacts to the metal, producing hydrogen. Care must be taken to ensure that all traces of the acids are removed. The original container substance is not readily water soluble and must be treated by steam method, the hot chemical solutions method. Alright, 226, hot chemical solution method of cleaning. Warning, wear head, eye protection, rubber glove with boots, aprons, heads, handling steam, hot water, caustic solutions, handling dry caustic soda, ash, wear, improve the respiratory protective equipment, long sleeves and gloves, high resistant hand pads and gloves to hand hot drums. Caution, aluminum and aluminum alloys should not be cleaned with the caustic soda and cleaners having a pH above 10 that may react chemically or other non-ferrous metals. Alloys investigate reactive power cleaning chemicals. Generally use the method of the triacetone phosphate strong washing powder. Commercial caustic cleaning compound dissolve it into the water concentration 2 to 4 ounces of the chemical per gallon water. Procedure of the hot chemical solution method of the cleaning is followed. Close with all the container openings except for the drain and filling connection or vent with the use of the damp wood floor or similar material, the ceiling cracks or other damaged sections. Alright, fill the container overflowing the water, preferably letting the water into through the drain, the no drain with the flush of the container with the insert of the hose through the filling connection with the vent. Lead the hose to the bottom of the container and the gas agitation from the bottom upward. The scum of the remaining liquid scum of the sludge carried upward out of the container. Drain the container thoroughly, completely dissolve the amount of the chemical required with a small amount of the hot boiling water. Pour solution over the container. Fill the container with water. Make steam connection for the container, even though the drain connection with the pipe and entering the filling connection vent. Lead the stem of the bottom of the container. Admit the stem to the chemical solution. Maintain the solution temperature at 170 to 180 degrees Fahrenheit. Intervals during the steam, adding water enough to overflowing any vial liquid scum or the sludge that may have collected at the top. Continue steaming at the point where an appreciable amount of volatile liquid scum and sludge appears at the top of the container. Drain the container. Inspect the inside of the container described in paragraph 224 F5. If it is not clean, to repeat steps 4 through 6 above the inspection again. Clean the containers within 15 minutes of the test of the concentration container described in 224.5.6. If the steam facility heating with the chemical solution not available, less effective than the method, the cold water solution amount with the cleaning compound increased to about 6 ounces per gallon of the water. Help with the solution to agitate with the rolling container by blowing air through the solution means with the air line with the insert near the bottom of the container. Another method used is cleaning the container to fill the 25% of the cleaning solution with the cleaning thoroughly with the introduced low pressure steam to the container, allowing to vent through the openings, continuing the slow steam of the container for several hours. 227 the mark safe of the containers. After cleaning, testing, ensure that the container is safe with the welding and cutting stencil and tag. The stencil tag must be also include the phase safe for welding and cutting and signature of the person certifying the dating. 228 filling treatment. Desirable fill the container water during during welding, cutting a supplement of any of the cleaning materials methods. When precaution is taken place, the container can be fine with a few inches of the prior point where the work is done. Make sure the space above the water level is vented that heat air can be escaped the container. Figure 2H of the safe way to weld container that had held combustibles. Shows the water and vent. Preparing the cleaning container with the welding cutting. Inert gas treatment. Inert gas treatment may be used to supplement any of the cleaning methods as an alternative water filling and treatment of sufficient inert gas. Mix flammable gas vapors mixture with a non-flammable continuous flow of any steam may also be used. Steam will reduce the air concentration because make air flammable gas mixture lead to lean burn. Permissible inert gas can include carbon dioxide and nitrogen. Are carbon dioxide and nitrogen. When carbon dioxide is a minimum concentration, 50% of the required except for the flammable vapor of the principally hydrocarbon monoxide, acetylene. In these cases, minimum concentration, 80% of the carbon dioxide is required. Carbon dioxide is heavier than air. During welding. The cutting operation will tend to remain in the container over the top of the opening. When nitrogen is used, the concentration should be used with 10% greater than those specified in the carbon dioxide. Do not use carbon monoxide. The procedure for the inert carbon dioxide and nitrogen treatment is as follows. Close all openings of the container, shift the filling connection, vent with the damp of the wood floor with a similar maneuver with the ceiling of the crack. The other damaged section, place the container with the spot for the weld and cut is on the top. That will fill it with as much water as possible. Calculate the volume of the space above the water level above enough inert gas to make the minimum concentration non-flammable. Will usually require a great volume of the gas. Calculated minimum. Since inert gas may tend to flow out with a vent after displacement, only part of the previous container of gas vapors. Introduce inert gas in carbon dioxide and nitrogen through the cylinder through the container drain about 5 psi. If the drain connection cannot be used, introduce the inert gas filling opening by the vent extent of the hose at the bottom of the container. Water level of the flammable gas head force out of the container. If using solid carbon dioxide, crush and distribute it evenly over the greatest possible area with obtain rapid formation of the gas. Precautions when using carbon dioxide: avoid bodily contact with the solid carbon dioxide, produce the burns, and avoid breathing large amounts of the carbon dioxide since it may asphyxiate, act as a respiratory stimulant, and in sufficient quantities can cause an asphyxiation. Inert gas concentration. Determine enough that inert gas is present using combustible gas indicator to instrument the inert gas concentration maintained during the entire welding cutting operation. Take steps to heat the high inert gas concentration during the entire welding cutting operation. One of the following methods. If gas is supplied with a cylinder, continue to pass gas into the container. If the carbon dioxide is used in solid form, small amounts of crushed solid carbon dioxide intervals greater than more carbon dioxide. Section 6. Safety precautions. Welding, cutting polyurethane foam-filled assemblies. 230. Hazard welding, polyurethane foam-filled assemblies. Warning, welding polyurethane foam-filled parts can produce toxic gas. Welding should not be attempted part filled with the polyurethane foam. Repair by welding necessary. The foam must be removed with the heat effective of the area would include residue prior to welding. General, welding polyurethane foam-filled parts and hazard procedure. Hazard of work is due to the toxic gas generated with the thermal breakdown of the polyurethane foam. The gas involved with the burning with the foam depends on the amount of the oxygen available. The combustible products of the polyurethane foam is clean hot fire with the adequate oxygen available to the air, carbon dioxide, water vapor amounts of the nitrogen, oxygen, carbon monoxide, trace of the hydrogen, cyanide, thermal decomposition, polyurethane, associated restricted amount of oxygen, as in case of welding operation, result of the different gases being produced. There are increased amounts of carbon monoxide, various aldehydes, isocyanates, and cyanides, with small amounts of phosphogens, and also will have the varying degrees of toxicity. Your safety precautions are strongly recommended when welding polyurethane foam-filled parts are not performed. If the repair is necessary, the foam must be removed with the heat of the affected zone. In addition, all residue must be cleaned with the metal prior to welding. And several assemblies of the M1 through 13 and M113A1 family vehicles should not be welded prior to removal of polyurethane foam through cleaning. Chapter 3: Printing, Reading, and Welding Symbols. Testing.